Assalamualaikum and hello everyone. So today we are going to present about the determination of vanillin and ethyl vanillin in milk powder by heat-speed solid phase micro-extraction coupled with gas chromatography mass spectrometry. Before I go further, let me introduce of our group members. The first one is Anis Naziha, Umi Najatun Nasuha, Aisyah Nadira, Muhammad Faiz, and me, Nur Azzaratun Nasuha. Back to our topic. So, what is vanillin? Vanillin is the primary chemical component of the extract of the vanilla bean. Vanillins including vanillin 3-methoxy-4-hydroxybenzaldehyde and ethyl vanillin 3-ethoxy-4-hydroxybenzaldehyde are important flavoring additive in food industry. Vanillin and ethyl vanillin are widely used as food flavor enzyme due to their vanilla aroma and strong milky flavor. In this video, we are using heat-speed solid phase micro-extraction coupled SPME with gas chromatography mass spectrometry to determine of vanillin and ethyl vanillin in milk powder. Solid phase micro-extraction is a relatively new sample preparation technique that has been steadily increasing in popularity since its development in 1990. Nowadays, many companies have introduced auto-samples compatible with SPME, which reduce the amount of manpower required per sample and increase the reproducibility. While gas chromatography mass spectrometry (GCMS) is an analytical method that combines the feature of gas chromatography and mass spectrometry to identify different substances within a test sample. So let's take a look at principal gas chromatography mass spectrometry by a part to a part. GC is also known as gas solid or gas liquid partition chromatography due to the distribution of compounds between the solid or liquid stationary phase in a column and the gaseous mobile phase. Figure 1 illustrates the separation of compounds in a GC. The sample mixture is injected, vaporized and flow into the thermally controlled column by an inert gas. The sample compounds can interact with the stationary phase through various intermolecular forces such as van der Waals forces and dipole-dipole interaction. Some compounds tend to interact more strongly due to their polarity, thereby resulting in higher concentration in the stationary phase compared to the mobile phase. As a result, these compounds are strongly retained in the column and have longer retention time compared to the compounds of weaker interaction within the stationary phase. So, for the mass spectrometry, mass spectrometry measures the mass to charge ratio of ion of a sample that can be solid, liquid or gaseous. The sample is ionized by subjecting the sample to a bombardment of the electron. The resulting molecules in the samples become charged and either fragment or retain their whole structure. These charged fragment or non-fragmented molecules are separated according to their mass to charge ratio. This involves subjecting them to an electric or magnetic field and calculating the deflected path of the charged molecule to a detector. The resulting spectrum is signal intensity of detected ion as a function of the mass to charge ratio. It is used to determine the masses of fragment or non-fragmented molecules and to elucidate the chemical structure. As discussed above, gas chromatography uses a capillary column to separate constituent in the sample by forcing a mobile phase containing the sample mixture through the length of the column containing the stationary phase. Each constituent in the sample will have a different affinity for the stationary phase and will, therefore, elute from the column at different times known as the diffusion time. Each component of the molecules that gets eluted at different time from the column is captured by the mass spectrometer downstream, which is then ionized, subjected to an electromagnetic field and gets deflected to a detector. The intensity of each charge fragment and non-fragmented component is calculated as a function of the mass to charge ratio. By coupling these two instruments together, it allows for more identification than any instrument is independent.
Faiz and I'm going to explain about the result and discussion. The experiment was conducted under the following parameter where the temperature at 70 degrees, oscillator rotation rate at 500 rpm, incubation time for 10 minutes and head-spread solid phase micro-extraction time for 20 minutes. Extraction effect on 7 different types of extraction fiber on a matrix standard mixture solution were tested and the results are shown as above. The result indicate that the peaks of analyte obtained from the 7 different types of extraction were well separated. The extraction capacity of 30 micrometer DVB or CAR or PDMS and 100 micrometer PDMS and 85 micrometer PA extraction fiber were relatively poor, while the 65 micrometer PDMS or DVB extraction fiber was the best. Therefore, 65 micrometer PDMS DVB extraction fiber was chosen based on the testing result. And for the incubation time, the vapor-liquid equilibrium was achieved by preheating the sample. When other parameters were kept invariant, the peak area change of vanillin ethyl and ethyl vanillin at incubation time of 10, 20, 30, 40 and 50 minutes were studied. The experiment results are shown as above. The peak area of analyte as the incubation time increased when the incubation time was greater than 40 minutes. The increase of the peak area was not apparent as the increase of incubation time, which indicate that the vapor-liquid equilibrium was achieved at 40 minutes. Therefore, 40 minutes was chosen as the optimal incubation time. Moreover, for the extraction time, the extraction time required for absorption equilibrium was studied when keeping other parameters invariant. As shown in figure above, the peak areas of analyte increase as time increased within 10 to 30 minutes. When the extraction time exceeds 40 minutes, the peak area becomes stable, which indicates that the vapor-liquid equilibrium was achieved at 40 minutes. Next, for the oscillator rotation rate, when other parameters were kept invariant, the peak areas of analyte under rotation rate of 250, 400, 500, 600 and 700 rpm were studied. As shown as figure above, the faster the rotation rate, the larger the peak was. This because the increase of rotation rate not only accelerate the evaporation of volatile component into gas phase, but also enhance the airflow in the airspace, which increase the extraction efficiency. When rotation rate was above 500 rpm, with the peak area no longer increased, therefore 500 rpm was chosen as the oscillation rotation rate. And for the extraction temperature, although high temperature helped to extract the analyte from the matrix, it could lower the partition coefficient of extraction fiber and reduce the extraction efficiency. At 65 micrometer PDMS or DVB extraction fiber was used to study the peak area change of the analyte at 40, 50, 60, 70, 80 and 90 degrees, while keeping other parameters invariant. The result indicate that the areas of vanillin and ethyl vanillin reach maximum value of 80 degrees.
For desorption temperature, after being adsorbed to extraction fiber, the analytes must be completely dissolved over a period. Desorption time of 2, 3, 4, 5 and 6 minutes was studied. As shown in the figure, the peak areas of the analytes no longer change at 5 minutes and would not respond even if dissolved again. Since high temperature could shorten the extraction fiber's service life, a desorption time of 5 minutes was chosen. For desorption time, the changes of the peak areas of the analytes under different desorption temperatures were studied when keeping other parameters invariant. The experiment result is shown in the figure. The response peak areas of vanillin and ethyl vanillin reached maximum values when the desorption temperature was 260 degrees Celsius. So, 260 degrees Celsius was chosen as the optimal desorption temperature. For the precision and recovery parts, standard vanillin and standard ethyl vanillin were spiked into 6 milk powder samples that is free from vanillin and ethyl vanillin respectively. After pre-treating as the sample preparation method, the spiked samples were analyzed. Recovery percentages were calculated using quantified level of vanillin and ethyl vanillin in spiked milk powder.
the results are shown in the table. Despite recovery of vanillin in the sample range from 90 to 99% and that of ethyl vanillin in the sample range from 97.5% to 100%. Their RSTs were 2.3 to 4.1 and 1.9 to 5.1% respectively. For the limit of detection and linear range, a blank sample was injected. The limit of detection of vanillin was 0.1 mg per kg and ethyl vanillin was 0.05 mg per kg. To construct the calibration plots, the standard solution of vanillin and ethyl vanillin prepared in deionized water were used. Vanillin and ethyl vanillin exhibit good linearity within the range of 0.1 to 2 and 0.05 to 2 mg per kg. The last part is sample analysis. Vanillin and ethyl vanillin contents in commercial milk powder samples were determined with the method established above. The overall number of the samples was 50. The concentration of vanillin and ethyl vanillin detected in the milk powder samples are summarized in the table.
From the discussion of the previous slide by my members, we can conclude that in this study, a method for the determinations of vanillin and ethyl vanillin contents in milk powder by gas chromatography was established. This method greatly eliminates the interference of complicated matrix in milk powder by simple pre-treatment. Despite recovery of the sample range from 90 to 100% and the RSD range from 1.9 to 5.1%, vanillin and ethyl vanillin perform a good linearity within the range of 0.1 to 2 mg per kilogram and 0.05 to 2 mg per kilogram, and the calibration coefficient was 0.9992 and 0.9991 respectively. We also find that this method possesses advantages in terms of high analytical efficiency, convenient operational process, and also the wide linear range. Therefore, the validated method is suitable for rapid determinations of vanillin and ethyl vanillin content in milk powder. So I guess that's all TMI we could share with you guys about the determination of vanillin and ethyl vanillin in milk powder. Hope it could help you guys to understand the topic, and see you again next time. Bye!